Calculus is a branch of mathematics that is concerned with the study of rates of change, slopes of curves at given points, area, and volumes bounded by curves at given points, areas, and volumes.
Economics, on the other hand, is one of the branches of social science that is used to analyze and describe the production, distribution, and consumption of wealth.
In our previous video, we have already showed the application of differential calculus to economics. Now, let us see the application of integral calculus to economics. Integral calculus is the idea to find the area under a curve of a function. Another term for integral calculus is integration. This can be used to find the areas, volumes, and central points. Basically, integral calculus develops methods for finding areas enclosed by curved boundaries. Integral calculus is the opposite of differential calculus or finding the derivatives.
Let us say that we have a curve wherein the value of y is equal to f of x. Now, how can we find the area under the curve or above the x-axis? The first thing that we need to do is to make boundaries in the graph and make some slices between the two boundaries. Each slice is denoted as delta x. To get the area of the curve below, get the sum of the areas of each slice. Summation of f of x times delta x. Take note, as delta x gets smaller and approaches 0 in width and approaches infinite n, the area under the curve approaches the true answer. Taking the limit of the area as n approaches infinity gets better approximation.
The symbol for integral is like letter S to represent the idea of summing slices. Beside the integral symbol is a function of the integral code integrand. And lastly, beside the function is dx, which shows that the slices go in the direction of x and approaches 0.
Integral calculus can be related to the concept of filling up a tank from a tap. Adding up bits of water or integrating its flow gives the volume of the water tank. But what about in economics? Economics is a dynamic field that involves both mathematical and non-mathematical formulations, basic economic theories, and principles.
A mathematical approach to economics is more concise, precise, and keeps us away from the unwanted and implicit assumptions. Much of the economic theories are presented in the mathematical and economic models. It is also used to clarify assumptions and implications. Integration is used to try economic models for optimization programs, comparative statistics, dynamic and statics analysis.
Integration in economics is the reverse of differentiation. This is used to find the area under the graphs and curves to find the value of shaded area such as Lorentz curve, revenue and cost, consumer and producer surplus, and investment and stock of capital. Now, let us look back at the class of Mr. Hernandez regarding the application of basic calculus in economics.
Morning, class. Seems like I was tested.
Calculus is... sir!
Now we are studying integral calculus. It's difficult to understand.
Have you forgotten what I have mentioned before?
Of course not, sir.
Good. Now, integral calculus is still related to economics.
In what terms, sir?
Tomorrow you will report the following. Try to research on the application of integral calculus in our class economics. Prichelle, Lorentz curve and Gini coefficient. Mareeya and Nav, revenue and cost. Khaila, consumer and producer surplus. And last, Aldrin, investment and stock capital.
Lorentz curve is a graph that shows the inequality of income of what the percentage of a country's income is being earned by a percentage of the country's household. This is defined into two. Number 1, x is greater than or equal to 0 and x is less than or equal to 1. That measures that proportion of something is held by the bottom x proportion of the population. L of x is less than or equal to x. Since the Lorentz function are measured from the bottom and they are non-negative and increasing, since there is no negative income. The x-axis shows the cumulative share of the people from lower to higher incomes. The y-axis, on the other, shows the cumulative share of income earned. The Gini coefficient or index is defined to be the ratio between the shaded area and the total area covered by the graph. It is a measure of statistical dispersion for income inequality. The numerator is the area between the local ideal Lorentz curve and the measured Lorentz curve. The Lorentz curve and the line of equality, and the denominator is the area beneath the line of equality. Always remember, the value ranges between 0 and 1. For example, if the area between the line of equality and the Lorentz curve is A, and the area under the Lorentz curve is A, therefore, the Gini coefficient is defined to be the A over A plus A. We say that the Lorentz curve is represented as L of x. Using the formula for integration, we can find the value of E as E is equal to definite integral from 0 to 1 L of x times P of x. So the formula for the Gini coefficient is G is equal to 2 times definite integral from 0 to 1 times x minus L of x and its derivative.
Example, find the proportion of the income earned by the bottom half of the population or under the Lorentz curve when the value of Lorentz curve is L of x is equal to 0.7x cubed plus 0.3x. Given x is equal to 0.50, bottom half of the population, L of x is equal to 0.7x cubed plus 0.3x. Solution, finding the area under the Lorentz curve. Substitute x to the equation. L 0.50 is equal to 0.70 times 0.5 cubed plus 0.30 times 0.50. L 0.50 is equal to 0.0875 plus 0.50. L 0.50 is equal to 0.2375. Thus, the bottom 50% of the population earns 23.75% of the total income.
Revenue and cost. In our previous video, we have defined that cost function is a total cost of the production given a specific quantity. Under this, it includes the fixed cost, which are the costs that do not change, and the variable cost, which is dependent on the level of production. The formula for the cost function is expressed as C of x is equal to F plus V of x, where F is a fixed cost, V of x is a variable cost, and C of x is a total cost. And revenue function is a total income from producing units. The total revenue is obtained by multiplying the price per unit and the number of units sold, and is expressed as R of x is equal to x times P of x, where x is the number of units sold, P of x is the price per unit, and R of x is the revenue function.
It is important in the field of economics to find the level of output for which the average cost is minimum. The minimum of the average cost can give necessary information about how to receive maximum profit. This can be calculated for solving for the derivative of the average cost. As a review, the formula for the average cost is AC is equals to C of x over x, where C of x is equals to F plus V of x. Therefore, the derivative of AC is 0.
And to get that value of x, for which d squared over dx squared AC is greater than 0, we also know the marginal cost is interpreted to be the approximate cost of one additional unit of input. It is computed as MR is equal to dC over dx is equal to d over dx cx.
The same goes for the maximization of the total revenue. Finding the maximization of the total revenue can help a firm determine whether the demand of the market is elastic or inelastic. This can be calculated by solving the derivative of the total revenue. As a review, the formula for the average revenue is R is equals to PX. Thus, R of X is equals to PX, or R of X is equals to X times P of X. Therefore, MR is equals to the derivative of R of X is equals to 0. And find that value of X for which the second derivative of R of X is less than 0.
The marginal revenue is also the derivative form of maximizing the total revenue. Using all the information that was stated, we all know that the marginal function is obtained by differentiating the total function. Now, when the marginal function and initial values are given, the total function can be obtained with the help of integration.
For the cost function, if C denotes the total cost and MC is equal to dC over dx is the marginal cost, therefore we can write that C is equal to Cx is equal to summation of MC dx plus K, where K is the constant of integration, and since it is the constant, it is the fixed cost.
On the other hand, for the total revenue function, if R of X denote the total revenue function and MR is the marginal revenue function, then MR is equal to the derivative of R of X. Therefore, we can write R of X is equal to the integral of MR dx plus K.
Now, let us go back to Mr. Hernandez's class to visualize how calculus is applied in revenue and cost.
For cost function, Iya is the owner of Chicken Publishing House. Nav is one of the employees. The marginal cost function of manufacturing X units of books in Chicken Publishing House is 5 plus 16X minus 3X squared. The total cost of producing 5 books is 500 pesos. Find the total cost function. Given, marginal cost is equal to 5 plus 16X minus 3X squared. Solution. C of X is equal to the integral of 5 plus 16X minus 3X squared times its derivative. C of X is equal to 5X plus 16X squared over 2 minus 3X cubed over 3 plus K. C of X is equal to 5X plus 8X squared minus X cubed plus K. So X is equal to 5 books and C of X is equal to 500 pesos. Substitute now the values into the equation. 500 is equal to 25 plus 200 minus 125 plus K. K is equal to 400. So the complete equation is C of X is equal to 5X plus 8X squared minus X cubed plus 400.
In the Chicken Publishing House, the marginal revenue function for a book is given by MR is equals to 12 minus 3X squared plus 4X. Find the total revenue and the corresponding demand function.
Integration is applied for development and inventions. Branches of science use it for certain experimentations. Its calculations are made to support certain foundations, which is why it requires a thorough analysis. Economics uses integration in supply and demand function, with costs and revenues that requires interpretation. Curves, graphs, and mathematical formulations, these are terminologies that might cause you a confusion. Integration then is there to sharpen your comprehension. It helps you understand through giving an introduction that in order to earn successfully, one must have an understanding and representation that all can be solved using differentiation and integration.
Example, suppose the demand function of a consumer is given by P is equal to 80 minus Q. If the price offered is P is equal to 60, find the consumer's surplus. Solution. For P is equal to 60, we get Q is equal to 20 from the demand equation. The actual expenditure PQ is equal to 1,200. Now, CS is equal to summation from 0 to 20. 80 minus Q multiplied by DQ minus PQ is equal to 1,400 minus 1,200 is equal to 200. Thus, the consumer's surplus is 200 pesos.
Today I feel like investing in everything. I can do it from my own bed. I'll call my broker through the phone or trade online all on my own. 'Cause today I feel like investing in everything. I'm gonna study stocks at SEQC of public listed companies. Nobody's gonna tell me I can. No, you know the stocks are the shares of ownership. If you wanna trade, check the ask or bid. Don't forget about the round lot. Oh yes, I said it, said it 'cause I can. Today I feel like investing in everything. I can do it from my own bed. I'll call my broker through the phone or trade online all on my own. 'Cause today I feel like investing in everything. Trading is fun.
For example, the rate of net investment is given by I of t is equals to 12t raised to 1 over t, and the initial stock of capital at t is equals to 0 is 25 units. Find the equation for the stock capital. Solution: k of t is equals to the integral of 12t raised to 1 over 3 derivative is equals to 12 3 over 4t raised to 4 over 3 plus c is equals to 9t raised to 4 over 3 plus c. As k is equals to 0 is equals to c is equals to 25, given k of t is equals to 9t raised to 4 over 3 plus 25.
Always remember what Andrew Fulgham said. It could be as little as we agreed to market ourselves together, or as much as we jointly entertain prospects or go after economic development elements identified in the diversification report.
Calculus, whether it may be differential or integral calculus, can help the economic status of a business, of a country, to discover and identify the exact values on how to balance the economic world.
Economics is too complex to understand, so as calculus. But the importance of these two yields to a system of mathematical analysis which is its logical development. It still constitutes the greatest technical advance in exact thinking.